choosing a string that you hope to prove cannot be pumped. And that's an art. Now remember, if the language you're talking about is a context-free language, then any string whose length is greater or equal to the pumping length of that language. Remember, each language. See, now that this is clear in my head, I now have a clearer vision about the pumping length, and I can say, maybe you'll find this helpful. Each language will have its own pumping length, right? Because for context-free language, it will have its own pumping length. Because what is that pumping length? Well, it's little b raised to this, right? So each language, what's a little b again? That was the maximum number of symbols in the rules, the right-hand side of the substitution rules. Okay, so for a different language, you have a different value for b, and mod v. Well, that's the number of variables, different variables in your language. Okay, so each context-free language will have its own pumping length. It'll have it. Okay. All right. So now choosing. Okay, so if the language is context-free, all strings that have a length greater or equal to that pumping length, greater or equal to little p, all of them, strictly all of them, can be pumped. Right? That's what the pumping lemma says. So to contradict that theorem, I only have to find one counterexample, because one counterexample kills the idea of all. Right? So I just need to find one counterexample, and so you go sniffing around and you try to find a candidate string, little s, that cannot be pumped. And how do you do that? Well, you choose a candidate string, and that's the hard part, the choice. Why do you choose this one rather than that one? But so choose one, and then try to pump it. Split it up, 5 ways: u, v, x, y, z. Split it up in those 5 substrings, contiguous substrings, and pump the v and the y either up or down, and see if what you get, the result of the pumped string, either pumped up or down, belongs to the language you're talking about. Now, if it does not, then you have found a string that cannot be pumped. But the pumping lemma says all such strings, greater or equal, whose length is greater or equal to the pumping length little p, all such strings can be pumped. But we found one that cannot. Therefore, we've got a contradiction, and therefore the language, go back and negate your original assumption, which was that the language is context-free, and you negate that. Therefore, the language is not context-free. Right? That's the general strategy. We had a similar logic before concluding that a language was not regular. Okay, again, proof by contradiction. So this strategy is quite familiar to you. You've seen it 5 times. You're going to see it 3 more times. Right. So the critical choice is the string you're going to use that you hope to show cannot be pumped. Right. So let's try this one. And you may ask, well, where'd that come from? Genius. Experience. So choose this string. Raised to power. They're all the same value. P, little p. The pumping. The pumping length. Now. You could choose others, just as long as they're all equal. You could choose, strictly speaking. Well, yeah. Well, when you see how how it proves, you could choose other things, but this is nice and simple. So we only have to find one counterexample, right? Just one string that that cannot be pumped, and then that's enough. We've found one counterexample. All right. So okay, choose this one. Now, obviously, this string S, it belongs to the language, right? Because look at it. Yeah, N, they're all equal. Well, PPP, integers, they're all equal. So, this string satisfies the description of the strings in the set. Therefore, this little s belongs to the set, belongs to language B. Okay? And its size, well, what is its size? Well, 3p, right? You got PAs and PBs and PCs. So the size of that string is 3p, which is obviously greater than... Jesus Christ. Wait a minute. Yeah, so 3p is greater than p. Unless, could p be 0? No, question mark. Alright, okay, so the string is greater than p, it belongs to the language, and you're assuming that b is context free, and therefore the pumping lemma applies, and therefore this string can be divided into 5 parts, u, v, x, y, z, and the u and y can be pumped so that the pumped string still belongs to the language, and the other conditions as well. What were they again? If you concatenate v and y, its length has to be positive. So in other words, you can't have both v and y being the empty string. Not allowed. And vxy as a substring, its length has to be less or equal to p. So that was the third condition. Yeah, right. Okay. Alright, so we now try to show that this string, you cannot pump it. Right? So if just one or more of those 3 conditions gets violated, then S cannot be pumped. And therefore B is not a context-free language. Right? Now, okay, so you play around with it. So which one? You only need one of those 3 conditions gets violated, and that's sufficient to say that S cannot be pumped. Right? So in the text, we're talking about condition 2. And what was that? That was condition 2 says that you cannot have both v and y being the empty string. You can't have them both being empty. Right? In other words, you cannot have, if you concatenate vy, the size of that vy, that concatenated substring, vy, cannot be 0. It's got to be greater than 0. So, in other words, either v is not the empty string, or y is not the empty string. Okay? You can't have them both being the empty string. Yeah, that's just it. Well, you can say it in different ways. So, either v is not the empty string, or y is not the empty string. Okay, not empty. Alright, so then you start looking at v and y, they're not empty. And remember, there are only three different terminals in your grammar. A, B, and C, little a, little b, little c, or just A, B, C. Okay? So you have two possibilities now. So we can look at v or y, and v or y. Let's concentrate on v. there's two possibilities now for V. And it's non-zero in length. Okay, so it has to have at least one terminal symbol, at least. So either that symbol, either that V, that substring V, either it does or it doesn't. So it's a two case. Either it does have only one type of symbol, for example, all A's, or all B's, or all C's. And the other case is, well, not that. In other words, you could have two or three different letters, A, B, and C. Fair enough. You want me to go over that again? So we're using condition 2. So that means either V or Y is non-empty, right? It has at least one symbol in it, and then now you have two possibilities. That V can either have symbols of just one kind, in other words, all A's or all B's or all C's. That's one possibility, and the other possibility is not that first one, and that means that V could contain either two different or three different symbols. Right? For example, A's and B's, or A's and C's, or B's and C's, or A's and B's and C's. Okay? Alright. Alright, so let's do the first case. That is when V or Y, same reasoning for either one. Well, let's concentrate on V. So let's say V now contains all A's. You could have just one A or more, but just A's, no B's, no C's. Alright? Okay. So in that case, when you pump once, so I don't know if you can see the second line here. Well, I'll just say it verbally and then continue on. So then, once you pumped it once, so you have uv squared x y squared z. Okay? And if your y was empty, so no change. So if you pump y and it's empty and you pump it again, I mean, if your y is empty and you pump it, y squared will still be the empty square, so that's no change. But v squared will now have more a's in it than before us. Sorry, v squared will have more a's than v. Okay, we'll have twice as many. Okay. Now before you pumped it, you had uv x y z, and now you've got uv squared x y squared z. So the v squared, the presence of the v squared, so now you have double the number of a's. So the number of a's, b's, and c's in the pumped string is they're no longer equal. That's critical, what I've just said. All right. Therefore, in that first condition, where there's just one type of symbol, one letter, for example, all A's, then that contradicts. It creates a string that cannot be pumped, because that with a v squared, now you've doubled the number of A's, for example. That string no longer belongs to the language, because it doesn't have the form of A to the n, B to the n, C to the n. You've got a contradiction. Okay, I'll just continue straight on.